वेलकम टू वेदादि क्लासेस में आपका स्वागत है. टुडे वी विल स्टार्ट द थर्ड चैप्टर ऑफ class 11th chemistry, that the classification of elements and periodicity in properties. So classification of elements. So, what we will study in this chapter? So, we will study. We have the different, so many elements. We have. So, to study one by one, and to study each and every element's properties individually is a very big thing. So, to make it summarized, they have been grouped and classified in groups and period, so to make it convenient to study. So that's why we study the that's why we have established a chapter, that's the classification of elements, in which we will classify the elements with their properties. With the properties may be on the basis of atomic mass, and the properties may be on the basis of atomic number. So in this chapter, we will start with the Daubernius triad law. What is the Daubernius triad law? Let's start with the Daubernius triad law. Daubernius triad law. So, what is the Daubernius triad law? So, if three consecutive elements of the same group have been taken in consideration, then the atomic masses, the arithmetic mean of the atomic masses of the first and third element will be equal to the atomic masses of the middle one. Have a look here. I just like to give some example. Like suppose we have, I'm giving the example of chlorine, bromine and iodine. Chlorine, bromine and iodine. This is the same group element, consecutive element. So atomic mass of the chlorine is 35.5. and the atomic mass of the iodine is 127. When we just take the arithmetic mean of this, so this will be 35.5 plus 127 divided by 2. So it will come near about 81.25. 81.25, and it have been found the atomic mass of the bromine, the middle one, is around 80. So this is approximately same. So this is the Daubernius triad law. It states that the arithmetic mean of atomic masses of the first and third element will be equal to the atomic mass of the middle element. We can give some more example. We have like lithium, sodium, potassium. Lithium, sodium and potassium. So what's about this? So the atomic mass of the lithium we have 7, and potassium, as you know, this is 39. So we just take the arithmetic mean of these two. 7 plus 39 divided by 2, so it will come 23. So the atomic mass of the sodium is 23 over here, 23. So this is the Daubernius triad law. Now there was the other rule. This is known as Newland octave rule. So what is the Newland octave rule? Newland octave rule. So octave means 8. So as you know, there are in a musical tone, there is something just like in sa re ga ma pa dha ni sha. Sa re ga sa re ga ma pa dha ni sha. Pa dha ni sa, just like this. So you can write in Hindi sa re ga ma pa dha ni sa. So each eighth one, 1 2 3 4 5 6 7 8, then each eighth one have the same tone, sa. On the basis of this Newland octave rule, it was given by John Alexander Newland. It was given by John Alexander Newland. And he states that each eighth element will have the same properties. So I just like to give you some example, like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. At that time, inert gas have not been discovered. So the eighth one, this is the first, second, third, fourth, fifth, sixth, seventh, eighth one was sodium. Again, then sodium, then again magnesium, then aluminum, silicon, phosphorus, sulfur, chlorine. And again, I told you the eighth one at that time is not discovered. So means inert gas have been not discovered. So eighth one will be again potassium. Now in the similar way, calcium like this. So this is if you start from here, 1, 2, 3, 4, 5, 6, 7, then this is the eighth one. Now, so when you classify these, then they will come in a one group. So it have been observed that lithium, sodium, potassium have the same approximately same characteristics or some common characters, some common physical and chemical properties. So they have been classified in the same group: beryllium, magnesium, boron, aluminum, carbon, silicon, just like this. So this is the Newland octet rule. But since at that time only 40 elements have been discovered. So this when the further elements have been discovered, then this rule was not applicable at that time. So this is the Newland octet rule. Now we just move to, according to the CBSE syllabus, now we just move towards Mendeleev's periodic law. So what is the Mendeleev's periodic law? So we have Mendeleev's periodic law. So what is the Mendeleev's periodic law? So Mendeleev's periodic law states that the physical and chemical properties, the physical and chemical properties of elements are the periodic function of its atomic mass or atomic weight. So Mendeleev states that as the atomic masses will change, so that's the physical and chemical properties of the elements will get changed. So this is the this is known as Mendeleev's periodic law. At that time, very less elements have been discovered. Only 63 elements have been discovered. So now we'll study about the what are the significance and what is the drawback or the limitations of the Mendeleev's periodic table. So Mendeleev's periodic table. So as you know, this vertical column is known as group, the horizontal column is known as period. This is a group and this is your period. So in a Mendeleev's periodic table, there was a 9 vertical column, and that was known as group. It is known as group, and these were 0, 1, 2, 3, 4, 5, 6, 7 and 8. So these are the 8 groups. Now, so how many periods? So actually the they have one more thing, that they have the subgroup. They have subgroup, and subgroup was A and B. A and B. And period is what? So actually there was a 6 period, but new Mendelian's theory said that it have 7 periods. So this is a 7 horizontal row. It is called period. Now, so what is the significance on? Let's start about the significance of Mendel's periodic. Significance of Mendel's periodic table. So what is the significance of Mendel's periodic table? Then first one. So first time he have given a systematic periodic table. So systematic periodic table. So it was first time. So first time systematic periodic table was given by Mendeleev. Now, so the second one, we have the he have corrected some doubts of atomic weight. So correction of atomic weight. So he have corrected the atomic weight of some elements, which he proved it is wrong. So how? Have a look here. So we have I just like to give some example, like beryllium. So beryllium, earlier the beryllium has the atomic number 4 and the atomic mass it was 13.5. Atomic weight or the atomic mass of the 13.5. But Mendel found that this is not correct. He told this is not correct, and he proved it wrong, and he have given justification in support of this. So he found what? So what he found? Have a look here. So he got the equivalent weight of equivalent weight of beryllium, that was 4.5 valency he got beryllium was 2. So he told that atomic weight is equal to equivalent is the product of equivalent weight and valency. So 4.5 into 2, it comes 9. So he corrected it as and he told that beryllium have atomic weight 9, is 13.5 is not justified. So this is the first time he corrected the atomic weight of some elements. And the most important work done by Mendeleev was prediction of new elements. Prediction of new elements. So what was the prediction? So he have predicted about some elements which have not been discovered yet. He have given some properties of those elements which will be discovered later on. So he have given like aluminium, and he have also given silicon, and there was one boron, that was the scandium. Now silicon means after aluminum there will be element which he have predicted about the atomic mass as 68. His prediction was 68, and density was 5.9, and very low melting point, and the molecular formula of the oxide was M2O3, and the chlorides at the MCl3. He got it for aluminum. Later on, when gallium have been discovered. So it have been found that gallium is nothing, it is Ica aluminum. In the similar way, he have predicted about the Ica silicon. Ica silicon, he have told about that atomic mass of the Ica silicon is 72, and the density is 5.5, melting point is very high, and the oxides molecular formula is MO2, and the chloride molecular formula MCl4. And when silicon have been discovered, so Ica silicon means germanium have been discovered. When the germanium have been discovered, then it is found that Ica silicon is nothing, it is germanium. Now, so germanium is the Ica silicon, and the Ica aluminum is the gallium. He have also given about the Ica boron. Ica boron. And when later on it was found scandium have been discovered, so it was found that Ica boron is nothing, it is a scandium. So this is a very good work done by, this is the major work done by the Mendeleev. But it have a lot of defects. So we study as the defects in the Mendeleev periodic table. So defects of Mendeleev periodic table. So what are the defects of the Mendeleev periodic table? Then first position of hydrogen. Position of hydrogen. Hydrogen have been classified in first group. It have been classified in group first. But hydrogen have both the tendency. Hydrogen have the tendency to lose the electron and to gain the electron. When it loses the electron, then it will have a character of metal. And when it gains the electron, it will have a character of non-metal. So when it loses the electron, so it behaves like alkali metal, like sodium. Sodium loses, if it loses one electron, then it will form Na plus. In the similar way, hydrogen also loses one electron to get converted into H plus ion. So it have the characteristics of alkali metals. At the same time, hydrogen have the characteristics of non-metal. Have a look here, as the chlorine gains one electron to get converted into Cl minus, and in the similar manner, hydrogen also gain one electron to convert into H minus hydride ion. Now in this case, what happens? Chlorine is a non-metal, is a halogen compound, so it forms chloride ions. In the similar manner, hydrogen form hydride ion. So gain of electrons taking place, so it's a non-metal. So it shows the characteristics of halogen, same as halogens. So it should be classified also in a halogen group, but it have been classified only the first group element, which is the alkali metal group. First group, which is the alkali metal. So this is a very contradictory thing. The position of hydrogen is still now the position of hydrogen is in the contradictory. Now have a look here. The second one, position of isotope. Position of isotopes. Isotopes is what? Isotopes are those which have same atomic number, the different atomic masses. Like we have H11, H12, H13. This is protium, deuterium, and this is tritium. Now, all these three have the different atomic masses. So they should be classified in different groups according to Mendeleev, because he have classified on the basis of atomic weight. So if the atomic weight will different, then it should be classified in different groups. But he have not given such type of any application or something like this. So he classified all the isotopes in the same group. So this is the drawback of the Mendeleev. Now third one is he have put, okay, The third one you can say the anomalous pair of element. Anomalous pairs of elements. What the meaning of anomalous pairs of elements? Have a look at. Now I just like to give you some example directly. So the cobalt have atomic weight is 58.9, and the nickel have atomic weight 58.7. So according to the Mendel's law, which have the less atomic weight should be written first, and which have the larger atomic weights should be written later on. But he have put cobalt first and nickel later. Although the nickel have less atomic weight and cobalt have more atomic weight. So this is the anomalous pair. This is not justified. So this is also considered the drawback of Rutherford. Drawback of Mendel's periodic table. Now, next one we have they have put the similar elements in different elements in similar group. Different elements in same group. What the meaning of this? So different elements means they will have the different properties, chemical and physical properties. So I just like to give you one example. Like we have some example like lithium, sodium, potassium. This is the first group element because and this is the alkali metal group. Alkali metal and alkali metal are the light metals, and these are very reactive metals. Yeah. In the same group, this is the first A group. You have considered as first A group, and in first B group, he have put some other elements like copper, silver, gold. He have put copper, silver, gold, like copper, silver, gold. Copper, silver, gold is what? Copper, silver, gold is heavy metals. These are very heavy metals. Means since these are heavy metals, this is less reactive. Very less reactive metals. Now both these pairs are copper, silver, gold are heavy metals and the less reactive, where on the other side lithium, sodium, potassium, the alkali metal is the light metal and the reactive metals. So how a same group can have the reactive metals as well as less reactive metals. So the properties of both the group first A and the first B are different, but still they have classified in the same group. So this is the contradictory thing, and this is the drawback of Mendel's periodic law. So this is the drawback of Mendel's periodic table. The next one, there is one more drawback, that is the position of element of group 8. Position of elements of group 8 element. In group A, each group have each group, suppose we have taken one element in each group in a single block. But in 8th group element, there is 3 elements in a single block. Like I just like to give like iron, cobalt and nickel. They have been classified in the single block. How this can be possible? A single block, there is in single block there is 3 elements. Like uranium, like Ru, RH, uranium, palladium, they have been classified in the same block. So it is not possible that one block have the 3 elements. So this is the contradictory. So the 4th, 5th and 6th period. 4th, 5th And the sixth period is this is the osmium, radium, osmium, and the platinum. This is considered as sixth period. So fourth, fifth, sixth period elements have been taken 3 elements in a single block. So this is not justified. Now the next one, there is one more drawback, that is the position of lanthanide and actinide. Position of lanthanides and actinides. So what the lanthanide and what the actinide? So after lanthanum is 57. After lanthanum there is 14 elements having same properties as of lanthanum is considered lanthanide. So after lanthanum, the 14 elements start from cerium. Cerium is 58 to lawrencium. Lutetium is 71. No? So these 14 elements are considered as lanthanides. And actinides starts from actinium. After actinium is 89, and after that 14 elements like thorium is 90 to lawrencium is 103. Now these are considered as actinides. Now have a look here. So he have not discussed anything about the lanthanides and actinides, which have been discovered in later on by modern periodic law. So this is the mainly periodic law. Now we have discussed about the different aspect, merit and demerit of Mendel's periodic table. So in the next video we will discuss some more thing about this one, but I just like to give you one more thing about the nomenclature part. Nomenclature, giving names. Nomenclature is nomenclature part. So what's about the nomenclature part? So we have more than 100. If the atomic number is more than 100, if the atomic number is more than 100, then how just give the name? So they have given the name just like this: for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So un, nil, bi, tri, quadra, pent, hexa, sept, oct, in. So this is this is given for the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you want to give the name 101, so this is 1 is sorry, what I have written over here. Wait a second. This is nil, on. So 1 is on, 0 is nil, 1 is on, and you have to use suffix ium by yourself. So on nil, nilium. So on nil, unium. On symbol will be u n u. Like you have to write 1, 3, 9. So you have, this is on, 3 is a tri, on, tri, in for 9, on you just use em, and this symbol will be u t e. So this is the way to write the IPC names of the elements which have more than 100 atomic number. So for today In next video, we'll discuss some more concept about the periodicity. So till then, goodbye. Take care.